lost the coding that I was working on because my power went out and I hadn't saved my code, which isn't that big of a deal because I can just redo it, but felt like doing Godot instead for now. And I'm basically just starting a new project, and I have no idea what I'm doing. Don't even have an idea of like what I want to make, but I think I kind of just want to try stuff and see what happens, and just get more familiar with the engine. I don't understand why my Firefox browser is so slow. It's weird. It's like if I open up a new window, it's perfectly fine. Well, okay, I don't know about perfectly, but hey Katie. Hey baby. An interface to a game world that doesn't create a window or draw to the screen directly. I might just watch a bunch of videos. Just like sit here for a while, trying to learn stuff.
Hey everyone, it's Guilherme, and in this video we're going to see how we can implement a 2D camera that keeps multiple targets in sight by following them and also zooming in and out when needed using Godot version 3.1. Let's begin by playing our game. We have two players and I can control both of them using either WASD or the arrow keys. This way I can move one far away from the other and vice versa. So we can see how the camera reacts to the movement of the players, and as you can see, the camera follows them, trying to keep looking at the center of the screen or at the center point between both of them. And at the same time, we also control our zoom, so we can zoom in and out depending on the position that the players are and how far away they are from each other. And of course, this camera also works with multiple targets, so if we like to, we could also add more than just two players. We could work with how many we want to. And by looking at the demo, we can also see that we have some offset here on the borders. The players cannot go out of the screen, either to the side or to the bottom or to the top. For us to better understand how this is working, I'm going to activate the debug mode on our follow camera. And here you can see that we draw a rectangle between our players. And when they move, we update this rectangle. And the center point here is where the camera tries to stay at. And by moving the players far away from each other, you can see that the rectangle expands, and if we move closer to each other, the rectangle shrinks until we get to a point where we cannot shrink anymore, because that's the zoom that we defined that we want to stay at. If we'd like to, as I said before, we could also add one more player here, and I'm just going to move it to the center of the screen. Press play again. And here we can see how the camera behaves when we have more than one point to follow. Once again, it's going to try to stay at the middle between all of them, and again shrink and expand based on the position of the targets. So in sum, what our script is doing is trying to draw a rectangle that is going to encapsulate all of the targets inside of it, and then find the middle point inside of that rectangle and follow it, and also update our rectangle when needed. Here on the game scene, as you can see, all of our players are children of our follower camera, and as we saw previously, that's how it works. It tries to follow its children, but this scene is not coupled to its children. This means that we can easily go to its scene and run it without having any children for it to follow. On the camera scene, we can define its offset, which are the offset between the borders that we saw previously, and also we can activate and deactivate our debug mode, which when activated is going to draw the rectangle that we saw previously when we were playing the game. Now let's open the follower camera script. To create those rectangles, we are using Godot's rect2 type, and in our ready function, we get a reference to our viewport rect because we're going to need it later. And we also set our process to false in case our children is lesser than 1. Now here on the process function is where we are going to start moving our camera and also changing the value of our zoom. So we begin by creating a new rect2 at the position of our first child with a size of 0. And for each child that this camera has, we're going to expand our camera rectangle by passing to it the global position of this child. When we are done creating our rectangle, we are going to set our offset to the return value of our calculate center. This is going to calculate the center position of our rectangle. This is why we are passing to it the camera rect, and we are going to calculate our zoom using our camera rect and the size of our viewport rect. And in the case that we are in debug mode, we are going to call update, which is going to trigger another draw call, as we are using the draw function to draw the rectangle and also the center of that rectangle. If we were not doing this, our draw function would not be called again, And because of that, we wouldn't be able to see our debug rectangle being updated. Now on the calculate center function, we receive the rect that we want to calculate the center of, and we return a vector2 from the function, which for the x is the x position of this rectangle plus its width divided by 2, and the same for the y value. On the calculate zoom function, we are once again returning a vector2, and as we saw previously, we are receiving the camera rect that we calculated in our process function, and also the viewport size that we are getting from our viewport rect. And here we create a variable called max zoom, and that is because when we are using the zoom functionality of our camera, if for some reason the value of our zoom in the x is different than the value of the y, we are going to get a different aspect ratio, and we are going to see some artifacts on our art. So what we do to make sure that this is not happening is to set the maximum zoom that we are calculating, which could be either on the x or the y, and we set that zoom to be the zoom that we are going to set in our camera. And to calculate the zoom, we are calculating both the zoom for our y and for our x, and for both of them we are getting the maximum value between 1, which is the minimum zoom that we want to have, and the width of our rect divided by the width of our viewport plus the offset that we defined on our exporter variable, and the same is done for the y value, but instead of the width we are using the height. So between those two values we are going to get the one which is greater, and then we are going to return a vector2 with the same value for the x and for the y. And finally we get to the draw function, which once again is being called on every frame if you have the debug mode activated by calling update. And because draw is called on the start of our game, we also check here if we are not on debug mode, and if we are not, we're going to return from the function. If not, we're going to draw a rectangle by taking the camera rectangle and setting it to a color of white, and we're also going to draw a circle .
indie studio Cerber Games made a video about a simple trick to make your 2D games 2 times faster. We tried it and it works great, so we decided to share the word. In this video, we'll show you how to use that simple optimization in short. If you want to get all the details, go see the original video and subscribe to that channel. The link's in the description. This trick involves turning the visibility of nodes off. For each visible sprite, every frame, the engine has to calculate if it's on screen to know what to render. It's quick for one sprite. The trick involves turning the visibility of nodes off. For each visible sprite, every frame, the engine has to calculate if it's on screen to know what to render. It's quick for one sprite, but the more you add, the heavier it gets. The good news is, Godot will skip any node with visibility turned off, and it will also instantly skip its children. So when you have a bunch of sprites together and they go off screen, you want to turn off the visibility of their parent. And you can do that easily with the visibility notifier. The exact performance gain will depend entirely on your project. If everything holds on one screen, you don't need this. But in the games most of us make, with big maps, this trick alone can double your frame rate, as shown by Cerber Games' video. In this demo, we have a bunch of generated rooms just to simulate a large level and test the optimization. Right now, the frame rate is pretty high, but it's 1200 roughly. And what's happening is Godot is checking every frame if every sprite in the level is on screen and has to be drawn. Now, I've made a checkbox, and if I turn it on, we'll be using visibility notifiers, one for each room. So if I turn that on, you can see the frame rate counter more than doubles. And this scales with the size of the level. The larger the level, the more the optimization will help. So the problem is that for each of the sprites, Godot needs to check every frame if they are on screen. Until it makes the calculations, it doesn't know. But we can skip those calculations by hiding the parent node, because if a parent is invisible, all the children are invisible. And we can use a node to make that fairly easy and efficient. This node is the visibility notifier 2D. So you want to add it as a child of the node that you want to toggle, our room in this case. And whenever the visibility notifier enters or leaves the screen, it emits a signal we can use to toggle visibility. The node draws a little bounding box that you want to scale to cover the entire area you want to toggle. Then you can use code like this. I first get the visibility notifier node, and in the ready function, I connect its screen entered signal to the show function, making my room visible, and I connect the screen exited signal to the hide function, hiding my node. Finally, you need to set the visibility of your nodes to false by default, otherwise you will not benefit as much from this optimization. It's because the screen exited signal will not fire at the start of the game, because it only fires when the node actually goes from being on screen to being off screen. And with that, you can enjoy much higher performance in your games when you have large levels. The amount of frames you will gain will depend entirely on the structure of your game. Note that to unlock the frame rate, like I have here, you have to go to Project Settings, and you want to search for VSync. It's on by default in Godot projects, and it will limit the refresh rate to your monitor. So if you turn it off, you can get higher frame rates and test the performance gain. As usual, you can find the open source demo on our website and GitHub. The link's in the description. This video and demo are sponsored by our courses. We have Learn to Code from Zero for beginners. It's a complete course to get you started with game development and has tons of lessons and interactive practices. If you're more experienced, you'll want to check out Godot Node Essentials. It's the biggest knowledge base about all the things you can do with nodes in Godot. Be creative, have fun, and I'll see you in the next one. Bye-bye.
Oh. Okay, but if you're putting nothing but wave files in your game, you're doing something wrong. Okay.
Let's talk about viewports. These nodes seem to be little known, but I use them all the time. In this video, I will present how I use viewports in 3 real games that I made in Godot. What does a viewport node do? Simple. It takes everything that is under it in the tree and renders it into a single texture. This generated texture can then be used as any other texture, for example, in a sprite. So why would anyone want to do this? Well, let's dig into our examples. Our first example will be from my very first Godot game, Save Eurydice. It's a 2-player tactical game. In this game, when a unit is defeated, a dissolve effect is applied on its texture. The dissolve effect is obtained by a simple fragment shader that we put on the texture rect of the unit here. But as you can see, only the image is dissolved and not the name of the unit, nor the strength, nor the black border around the texture. We would like the shader to treat all that part of the tree as one, to dissolve it together. So to do this, we'll add a viewport node, and the viewport node will display everything that is under it as a single texture. So we'll have to set the size of this texture. We'll set it as before. Okay, as you can see, the viewport now creates a texture here from everything that is under it. To display this texture in the game, there's a cool viewport container node that displays the viewport. Now that all our elements are treated as a single texture, we just have to get the material, put it on the viewport container, and remove it from where it was before. And now everything is dissolved together. Our second game for our second use case is MadBlocks. It's a physics-based Tetris game, and you can play it alone or with a friend. It's really fun and it's free, so I really recommend you to try it. In this example, we'll focus on the layout of the UI. As you can see, on the left we have the real playing area, which is composed of Node 2D, physics node, etc. And on the right we have the UI with info for the player. So right now the structure of the window is okay, but what if in the future we want to change this structure and put the play area on the right and the rest of the UI on the left? What if we could use the power of Godot control nodes to move around complex scenes composed entirely of Node 2D nodes? This is exactly what the viewport container node does. If you put a viewport under it and then the rest of your playing area under the viewport, it will be generated as a texture rendered by the viewport container. You can then move around this texture as if it was a normal control node. So now, if we want to switch the position of the playing area with the position of the UI, it's as simple as taking this, putting it here, et voila! Our final example will be from the game we are currently working on, A Good Day. It's an action online multiplayer game in which one team, the teens, tries to collect collectibles and retrieve them to their starting area, and the other team, the adults, try to stop the teens from doing so. So here is a simplified project of what we want to do. We have an animated sprite of a flower which is moving in the wind, and we want to decorate our game by putting a lot of these flowers everywhere in the scene. So I've made a simple scene that tries to instantiate 7500 of these animated sprites. When we launch the scene, we can first see that it's very long to launch. So maybe use this time to like the video if you like the content, and subscribe to the channel for future videos. And now that the scene is launched, we can look at the profiler, and as we can see, we are over the line representing the budget for 60 FPS. So what is taking a long time here is the fact that we have 7500 sprites, but we also have that many times the logic to animate the sprites. But what we really need in this example is 7500 sprites, but only 1 times the logic. And of course, we can do that with viewports. Here, one viewport will render a texture with 1 animated sprite. And then, in our main scene, we will instantiate a lot of sprites that will only display the texture created by the viewport. Let's try with 7500 sprites. First, loading the scene is a lot faster. And when we look at the profiler, we can also see that we are far below our frame budget. Just for fun, let's try to instantiate 75,000 sprites. Of course, it takes a longer time to launch. But we are still just within our time budget. That's it. In this short video, we managed to go through 3 viewport examples from real games. It turns out being able to render small views of a scene is really useful. I hope you liked this video. Don't hesitate to leave a comment on how you use viewports. And we will try in the future to make videos like this.
just gonna follow another guide. Because why not?
I honestly believe that this is one of the first things that you should learn as a Godot beginner once you've mastered the basics of the engine. Alrighty, it's another devlog with some progress on my game so far and also some tips for the progress on my various. I still needed to figure out how to make the combat work. It was a mix between I had to do. Create my first head hill and don't even get me started on managing the actual sprite animations. If your logic code is starting to look like a tank, hell. So the next day I realized that I couldn't rely on the monkey brain alone, and I did some research on how smart people would handle like game character states. And that's when I discovered state machines. When you are creating a game, especially a platformer, your character will likely have different states, like running, jumping, or attacking. When your character is running, it is allowed to jump, and when it's jumping, it can only fall, for example. You could manage all of this with a bunch of if statements, checking what state the character is in or is not in, and then run the specific code. But as your game grows, this can get really messy and hard to keep track of. This is where a state machine comes in handy. Instead of cramming everything into a big script, a state machine lets you break things down into separate, clear scripts for each state. So when your character is running, only the code related to running is active. When the character switches to jumping, the game automatically swaps out the running code for the jumping code. This approach keeps your scripts much more organized and easier to understand because each script only deals with the functions and behaviors that are specific to that particular state. It makes your code cleaner, but more importantly, it also makes it more maintainable. You can easily add different logic along the way as your game grows. I honestly believe that this is one of the first things that you should learn as a Godot beginner once you've mastered the basics of the engine. Learning the fundamentals of object-oriented programming, where specific code can independently function in its own state without interfering with the rest, is a game changer. Once you grasp this concept, it will influence everything you program from that point onward. I'll be sharing a few helpful videos in the pinned comment and the description of this video that you should check out next. And while this video isn't necessarily a tutorial video, I will show you how I roughly implemented the state machine to make the combat work. Alright, let's just...
Hello and welcome to the intro video to the GDScript Fundamental Tutorial Series. In this video, I just want to talk about the goals of the series, along with who the audiences are, and the best of data, which tells the compiler how the programmer intends to use the data. Data types define the operations that can be done on the data, the meaning of the data, and the way values of that type can be stored. Let's go ahead and take a look at the dictionary definition of a literal value. A literal value, also called a literal, is a value that's written directly in the source code as opposed to being the result of some other expression, such as referencing a variable or a constant. Think of a literal value as something you literally provide in your script. Let's go ahead and take a look at some of the common data types you'll be using in versions represented directly or in fact a string. There are similar to int, only have two, have no, written out exactly as that. Let's go ahead and take a look at the string data type. String is a data type used in programming and is used to represent text rather than numbers. It is comprised of a set of characters that do is you overflow, wrap around, and come out with the minimum value in the range. Let's take a look at what overflow and wraparound you're allowed to use. We have the integer data type. An integer is a data type that represents some range of mathematical whole numbers. Let's take a look at what overflow and wraparound means. So if you take the minimum value, subtract 1, what you will do instead is get the maximum value for that range. That is what an overflow and wraparound looks like. The same can be true for taking the maximum value possible, and when you add the value of 1, the opposite of this can be true. If you take the maximum value and add 1, what you will do is wrap around to the lowest value possible. Let's go ahead and take a look at other integer literal examples. As you can see, we can do positive numbers, negative numbers, and the decimal point. Next in the list is the float data type. A float data type is a float 12.30. What we'll do instead is turn these numbers. The boolean is a data type that has one of two possible values, either true or false. The true or false values are used to represent two truth values of logic and Boolean algebra. In GDScript, when converted to numeric values, false becomes 0 and true becomes 1. If you were to convert these into float values, false would become 0.0 while true becomes 1.0. Keep that in mind. Booleans are pretty simple. Here are examples of what a Boolean literal would look like written out in GDScript. They're fairly straightforward. All you have to do is around it. GDScript no is an empty data type that contains no information and cannot be assigned any other value. No's are pretty straightforward. All you have to do is type out no to the compiler to let it know that this is a no data type. That's it for this episode. Let's go ahead and understand the dictionary definition of data types. A data type is... Let's take a look at the
Man. I probably should watch this.
Dictionary definition of a variable. In computer programming, a variable, also called a scalar, is a storage address paired with an associated symbolic name which contains a known or unknown quantity of information, often referred to as a value. In layman's term, a variable is a container that contains a value. Now, how exactly do we go about creating a variable? Well, in GDScript, to write a variable, you type out the keyword var, spelled VAR, followed by a unique name. This is important because a variable cannot have a name that already exists in your script. Now, to write a variable, you simply write out the keyword var, spelled a literal value or data object using the assignment operator, which is represented by the equal sign symbol. Now, let's go ahead and take a look at two examples. In the first example, you can see here we've created a variable called player health, and we've assigned it with the assignment operator the literal value, in this case the literal integer value of 100. You can also create the same variable without assigning a value. In this case, we've created a variable called player health, and we have not assigned it any value. As a matter of fact, if we do not assign a value to our variables, they will contain the data type null by default. And again, variables must have unique names or an error is thrown. In GDScript, you can also use something called typed variables. A typed variable is just a data type that is explicitly declared on your variable by adding the colon symbol followed by the data type in which you wish to limit your variable. In this case, the first example is a variable called life points, and using the colon sign symbol followed by the int keyword, what we're saying is that our variable called life points can only have integer values assigned to it. Declaring data types on variables is usually considered good practice, as it leaves less room for confusion on the purpose of the specific variable. Assigning a value that is not the declared type will throw an error. Let's go ahead and take a quick look. In this case, we have a variable called text, and we've entered value script. And to coerce a value to be a certain type, use the casting operator as. In the first example, you can see we have a variable called text with a declared data type of string, and we are assigning it the value 10 as a string, what this will do is convert the integer value 10 into a string value 10. The second example, we have a variable called a num, and we assign it the string value 10 as an integer. What this does is it converts our string value of 10 into an integer, and we assign it into a float, which will then be assigned to our variable called num float. Common data types you may find yourself using with your typed variables include integers, booleans, strings, and floats. Instead of typing them out, you can also infer the data type onto your variable called the and the object that is the subtype of the cast type. Now, this is an advanced topic as we have not, nor will we be going over Godot specific classes. If you want to learn Godot specific classes, please feel free to view my Godot Basics tutorial series. Regardless, just for your information, GDScript does have the ability of casting classes. So in this case, you can see here, we have a variable called my_node2d with the data type of node2d, which is a Godot specific class, and we are assigning it some type of sprite class value, and we are casting it as a node2d. Just so you know, the sprite class is a subclass of the node2d class. And again, a more advanced topic, however, we will be going over classes in a later episode. Now that we have gone over different ways of declaring our variables, I have laid out the actual format for declaring variables in GDScript. Again, the mandatory pieces of a variable is the keyword var followed by your data type, and you also have the option assigning both the values. Quickly go over when you need to use variables. You should use variables when you have data that needs to change over the lifetime of the game or program. In this example, we have a variable. Let's go ahead and take a look at the dictionary definition of a variable. A variable, also called a scalar, is a storage address paired with an associated symbolic name which contains a known or unknown quantity of information. To better understand what a variable is, we need to first learn life cycles. So what is memory life cycle? Basically, a memory life cycle is the time between an object's creation and its destruction. No matter the programming language, memory life cycles are the same. You first allocate memory, then you use memory, lastly you release that memory so you can allocate new memory. The first step is allocating memory. Memory is allocated by the operating system, which allows your program to use it. All computers have memory, also known as RAM. It's also referred to as random access memory. Memory can be thought of as an array of bytes. Let's go ahead and take a visual look at this. As you can see here on one side we have address memory location and the other values. This is what it looks like more or less. You have addresses on one side and a value associated to the address on the other. After the operating system has allocated memory to the application, you can start using it. Read and write operations are happening as you are using the allocated memory, such as assigning and changing variable values in your script. Lastly, when you are done using the memory, the operating system will release the memory. When variables are no longer in use, you can release the entire memory so that it is freed and can be used to allocate new memory. This can be done manually or automatically depending on the programming language you are using. One thing to keep in mind is that the operating system only determines how much memory is allocated to your application. However, your application's programming language determines how memory is handled. One tip I have for you on memory usage is that the less memory you use, the better it is in general. For games, using less memory takes into consideration the performance for users who are using lower size RAMs and CPUs in their computers. One thing to note is that if there is enough space, the operating system will allocate more memory from RAM to your application if your application uses more than the allocated memory that was previously assigned to it by the operating system. If you go over the RAM limit, the operating system will start allocating memory to your application from the hard drive or solid state drive. One thing to note is that using hard drive or solid state drive for memory is slower than using RAM. Let's take a look at the basic variable process. We have a variable x which equals the literal integer 2020. First, the application will allocate enough memory for the variable, in this case, enough memory to hold an integer. Second, the application will assign the value 2020 to that memory address location. Third, the application will indicate to the variable x that it needs to point to that value. Lastly, depending on the language, memory is freed when not in use. Let's go ahead and see this visually with the C language. We have an integer x which equals the literal integer value 2020. As you can see here, we have our integer x, which has been assigned a memory address location, and it has also been assigned its value 2020. So basically the memory address location has the value of 2020. Let's go ahead and create a second integer y which will equal x. As you can see here, x still has the same location and the same value. However, the application has created a new location memory address for y. However, it's still assigned the same value as x. Keep in mind that the application has created different location addresses for x and y. However, the values are the same for x and y. Let's go ahead and modify the value of y. As you can see here, we have now assigned the literal integer 0 to the integer y. Notice here that the location for y remains unchanged. However, the value has now been modified to 0. You can change the value of y or the value of x as many times as you want. You will never change the location address in memory for either of these values. The way the C language handles memory is a good thing as it decouples the memory address of x and y, meaning that you can change the values of x without changing the values of y, and you can change the values of y without changing the value of x. This is possible because both x and y are pointing to two different memory address locations in the application. Now that we have a basic understanding of how the C language handles memory, let's go ahead and take a look at
Godot uses reference counting. What this means is that instead of using garbage collection to remove from memory unused code, Godot uses reference counting to determine whether or not something should be removed from memory. Let's go ahead and take a look at how Godot handles the execution of this line of code. So we have a variable x which is equal to the literal integer 2020. What Godot does is it creates an object. Then it sets the type to integer. Next, it sets the value to 2020. Then it creates a name called x. It points x to the new object, and then it increases the object's reference count by 1. As you can see here, the memory layout is different than the memory layout previously shown with the language C. Instead of x owning the block of memory where the value 2020 lives in, the newly created object owns the memory where 2020 lives. The name x doesn't own any of the memory address. Since Godot uses reference counting instead of garbage collection, what this means is that as long as the object has a reference count greater than 0, the object will continue to exist in memory. Let's go ahead and create a new variable y which will equal x. As you can see here, our application goes through the same process it went through to create the value of x. However, instead of creating a new object, what our application did, in this case what Godot did, is that it created the name y and it pointed it to the object that has the value 2020. Basically, it points the variable y to whatever x was pointing to. As you can see here, the object now increases its reference count by 1. But what happens in memory when we assign a new integer value to y? Well, in this case, the application, or rather Godot, creates a new object with a new address memory to contain that new value. Then what it does is it takes the name of y and it points it to that object. So while x is still 2020, our y is now 0. Let's go ahead and take a look at what happens when we change the value of x. As you can see here, our application Godot creates a new object with a new memory address. It creates the type, it creates its value, it points x to this object, and it increases its reference count by 1. As you can see here, x is pointed to this object, y is pointed to another object, but nothing is pointing to our previous object, which is 2020. As you can see here, the reference count is now 0. What this tells the application Godot to do is that it needs to release this object from memory. This is basically Godot's way of memory management. One tip I have for you is that nodes in Godot are not reference counted in the engine. What this means is that removing a node from the tree will not delete it. Many people will use remove child thinking it removes it from memory. However, this is not the case. To better manage nodes, create a pool of objects and reuse the node object. You can also explicitly destroy the node from memory by calling q free in the exit tree, which is called when the node is removed from the tree. So what exactly are operands? Operands are numerical text and Boolean values that a program can manipulate. Operands can also be object values. In this case, the operands are 1 and 2, along with the variables x and y. Now, operators are symbols used to manipulate and check operand values. In this case, our operators would be the addition sign and the subtraction sign. Other common signs, such as the multiplication and division symbols, are also operators. Let's take a look at assignment operators. Assignment operators assign a value to its left operand based on the value of its right operand. The simple assignment operator is the equal sign, which assigns the value of its right operand to its left operand. In this case, we are assigning the variable x with the value that is stored in the variable y. Here are some other assignment operators you'll be using in GDScript. You have the additional, subtraction, multiplication, division, and remainder assignments. You can write these out by saying that the value, or rather the operand on the left, will be assigned the values of x plus y. You can also use the shortcut version x plus equals y, which is the same as writing out x is equal to x plus y. On the left side, you'll notice the written out version, and on the right side, you'll notice the shortcut version. These are fairly straightforward assignment operators that do exactly what you see. Addition adds, subtraction subtracts, multiplication multiplies, division divides, and remainder. The remainder assignment operator is a special case operator in which it gives you the value, or rather, the remainder of the division. So if you want the result of the division, you use the division assignment operator. However, if you want the remainder of what you divided by, then you use the remainder assignment operator. You'll most likely never use this unless you're doing something special with it. But just keep in mind, if you want an easy way to get the remainder of your division, this is the operator you will use. Let's take a look at the comparison operators. A comparison operator compares its operands and returns a logical value based on whether the comparison is true. In this case, the logical value will be a Boolean value. Now, to see if two operands are equal, use the equal operator. The equal operator, if you end up using one equal sign, what you're doing is you're assigning the right operand to the left. So just keep that in mind. To see if two operands are not equal, use the not equal operator. In this case, the not equal operator is an exclamation point followed by an equal sign. And what you are trying to convey is if x does not equal to the value on the right, in this case 1. Now, if x is equal to 1 and you follow this operator, what you will be returned is the value false. Now, if the value of x is any other value than the number 1, then this operator will return the logical value true. Moving on, to see if the left operand is greater than the right operand, use the greater than operator pointing to the right. In this case, you want to see if the left operand x will return the left arrow symbol. And what you are trying to convey is if the right 1 equals 1 or number script bigger than 1, then this operator will return false. Let's move on to the logical operators. In GDScript, there are 3 logical operators: the AND symbol, the OR symbol, and the NOT symbol. Let's take a look at the AND symbol first. The logical AND operator is denoted by the 2 ampersand symbols or the word AND in GDScript. It will return false as long as any of the operands can be converted to false, starting from the leftmost operand. Let's go ahead and take a look at how the logical operator operates. So we have a variable x which is equal to true, and the logical operator AND. So we're checking to see that x and 1 can be converted to true. Now the logical operand will first check to see if the left operand can be converted to false. If it can, the value false will be returned. Otherwise, it will check to see if the second operand can be converted to false. If the second operand can be converted to false, it will return false. Otherwise, it will return true. So let's take a look at how this works. Since variable x is equal to true, our logical AND operator will first check the left operand, in this case the variable x. X can be converted to true, or rather x is true, so therefore the logical operator moves on to our first operator, or the word OR. Between converted strands can be now the like with the x can't be true. I'd like a single can find converted to true. Otherwise, it will return true. A little confusing, but let's go ahead and take a look at this example here. We have a variable x which is equal to false. We use the not true operator value in a logical value, whether you're converted to the or no, your value in the not operator will always be true. So what exactly are constants? In computer science, a constant is a value, the keyword const, spelled C-O-N-S-T. Basically, a constant declaration format looks like the following. You have modifications are not permitted after declaration and assignment. Let's take a look at a quick example. We declared a constant, value never changes, and assigned it the literal integer 1.
Okay.
Somewhere in the code after the declaration,
It's still doing it.
if we try to
The heck?
value never changes. In this case, we're trying to assign it the value.
Is that
In this
me?
course, Tristan Wilcox will teach you how to produce.
Oh, I think it's the video.
100. This will throw an error.
Hello and welcome to this course on
Yeah, must be
in
the
GD.
video. What?
GDScript. There are
Weird.
pros when using constants. So what exactly are comments? Welcome back to the GDScript Fundamental Tutorial Series. In this episode, naming conventions are a set of rules for choosing the character sequence to be used for identifiers, which denote variables, types, functions, and other entities in source code and documentation. One thing I notice about beginners is that they have problems with variable naming. What I mean by this is that beginners don't spend quite enough time on naming variables or functions. Sometimes beginners use single characters to name their variables. And while single characters were okay back when computers had small RAM, when there were consequences with giving variable big names, that is no longer the issue. So how exactly can we go about creating good variable and function names? Well, to start, the intention of the variable or function should be clear from its name.
One thing to avoid are using comments to explain your code. If you have to write a comment to make the purpose of the variable or function clear, it's best to start rethinking a new name. Let's go ahead and take a look at bad variable names. Over here you can see we have a variable x assigned the literal integer value 100. And on top of that, you can see above our code that we have a comment that says represents player health. This is not good use of writing code, as now you have to read 2 lines of code, the comment and the variable declaration. Also keep in mind that reading the variable x throughout the script will cause confusion, simply due to the fact that you don't know what x represents unless you go back to reading the comment. Let's go ahead and improve the state of our code. As you can see here, instead of naming our variable x, we've decided to rename our variable player health. On top of that, we were able to get rid of the comment because the name of our variable lets you know what this variable's intent is, which is to contain the value for our player health. As you can see here, we have only 1 line of code to read. And on top of that, player health as a name makes the variable self-explanatory. If we see this in our script, we know we are doing something to the player's health. However, what if I told you there was a way to even improve our current code? Let's go ahead and take a look at that. As you can see here, we've added a data type to our variable. In this case, we are limiting the scope of our variable to only taking integers. Now when someone looks at our code, that coder will understand that the player health only deals with integers and of course all the mathematical operations intended for integers. One thing to keep in mind when naming your variables is to avoid writing data types in the name. This is due to the fact that if you decide to change the variable data type in the future, you will cause yourself a lot of headache. Let's take a look at this example. In this example, we have a variable int health assigned the literal integer value 100. Maybe a user accidentally changes the data type. You can possibly be misguided by other users on the data type if the data type changes in the course of the game. What I mean by that is that even though you have the variable int health, what if in the future they decide to opt in an integer for a string? Well, now you have to not only change the variable name, but you have to propagate the name changes throughout your code, and that's not something you should be looking forward to. Instead of opting to put a data type in your name, just go ahead and declare it as a specific data type for your variable. In this case, you can see here we've changed the variable name to health, and we've declared an integer value to our health. The intent is clear, causes error if a user accidentally performs an operation that changes the data type as well. As you can see here, we've decided to add a data type to our variable, and basically added type security to our variable. One thing I suggest to make life easier on your coding adventures is using names that can be easily searched in your coding editor of choice. Let's take a look at an example. As you can see here, we have a variable x1, and that's not very searchable. On top of that, the name of our variable doesn't even explain the intent of our code. As you can see here, instead of x1 and y1, we've opted to name our variables width and height. That's a little better. At least we know that the variable contains something to do with width and height, but that's just me. You should use whatever you are comfortable with. But no matter what, you need to decide a standard for names. The way you make names should be consistent across the board. For example, consider using camel case for variables, functions, and classes. Consider using all uppercase for constants. As an example of camel case, let's take a look at this code right here, player height. Player height is, as you can notice here, we have a lowercase g and a capital P. How many words are in the name? This is to make sure that constants can be visually seen in your code compared to variables and other elements. With class names, I prefer to use Pascal case. Every word, including the first word, will have the first letter capitalized. As you can see here, we have a capital M and a capital P. These are just tips and preferences I like to use. However, feel free to pick whatever naming convention you feel comfortable with. Just make sure you stay consistent throughout your entire code base. That's all I have for you in this episode. I look forward to seeing you in the next. Hello and welcome back to the GDScript Fundamental Tutorial Series. In this episode, we'll be going over the if, else if, and else statements. Let's get right to it. As you probably know, Godot uses control statements to control the flow of execution in your code. One of these are the conditional statements if, and else keywords. Let's go ahead and take a look at the if statement chain. An if statement chain is a control structure that executes one block of statements if a certain condition is true, and a second block of statements if it is false. Now let's go ahead and take a look at the if statement. An if statement starts the if-else statement chain. Only one if statement is allowed to be used per chain. As you can see here, we have 2 separate if statement chains. An if statement checks a test, and if the test is true, goes ahead and executes everything in the statement block. In this case, if the test comes out to false, we're going to skip the statement block and execute nothing. Let's go ahead and take a look at another example. This is the if-else-if combo. The else-if has to precede an if statement. You can provide multiple else-if statements in your chain. In this case, as you can see here, we have an if statement, and if the test is false, we move on to the else-if statement. If the else-if statement is true, we execute everything in the block of code in the else-if and exit the chain. However, if the else-if test is false, we're going to go ahead and skip everything in the statement block and exit our chain. Let's go ahead and take a look at an if-else statement chain. One thing to note about the else statement is that the else statement must be at the end of the chain. The else statement ends the if-else-if-else chain and executes the statement if all tests fail. And this in the else statement block and execute the code in the else using a lot of the times. This is basically an if-else-if and else statement chain. You can also refer to this as a nested if-else statement. In this case, all the same rules apply. If the test in the if line comes out true, we execute everything in the statement block for the if and exit. Take a look at the basic if statement flowchart. As you can see here, we are starting at the top of our code, and we went ahead and moved into our if test expression. Now, as you can see here, if the test expression comes out to true. Welcome to another episode of the GDScript Fundamental Tutorial Series. In this episode, we will be talking about while loops. A while loop is a control flow statement that allows code to be executed repeatedly based on a given Boolean condition. Let's go ahead and take a look at the while loop code. In this case, we have the word while followed by the test expression. The test expression is going to evaluate to either true or false. If the test comes out to true, we enter the block of code in our while loop. However, if the test expression comes out to false, we exit the while loop. It's better to explain a while loop with a flowchart, so let's get right to it. As you can see here, we started our code at the top and we've just entered our while test expression. Now, if the test expression comes out to be true, we enter the statement block, run the code in the statement, never really exit the while test expression. When you can't exit your while loop, we call that an infinite loop. Let's go ahead and talk about that. An infinite loop, sometimes called an endless loop, is a piece of coding that lacks a functional exit so that it repeats indefinitely. Basically, an infinite loop is the opposite of a loop loop being a sequence of instructions that is continually repeated until a certain condition is reached. There are three types of infinite loops you'll find yourself running into in any coding environment. You have fake infinite loops, intended infinite loops, and unintended infinite loops. Let's go ahead and look at the definitions of each type of infinite loop. First, we'll start off with the fake infinite loop. A fake infinite loop is called fake because they give the impression that a loop is infinite. Basically, it looks like an infinite loop, but in reality, it's not. Let's go ahead and take a look at this line of code. If we look at the first line of code, while true, we can see here that we will never exit this while loop. However, if you look at the second line of code, you can see we have a break statement. Basically, that means we're going to exit our loop. Our loop is only going to run one time because of the break statement, so therefore, this is a fake infinite loop. At first glance, it looks like it will never end, but in reality, it only runs once. The next type of loop is the intended infinite loop. An intended infinite loop is an infinite loop where the user intentionally doesn't want the loop to end. Now, you may be wondering, in what world does a programmer or coder want an infinite loop? And that's a great question, so let's look at an example of an intended infinite loop. Basically, when you run GDScript and you press the play button, you are entering an intended infinite loop created by the compiler. This is intended as the game wants to run every script on every frame indefinitely until the player or user wants to exit the game. Now, the last type of loop is the loop you want to avoid at all costs. As its name suggests, this type of loop is one where the user made a mistake. Basically, the user or coder, or rather, the programmer, forgot to exit out of the loop by accident. In most applications, an unintended infinite loop will always certainly freeze the app when running.
Hey. How's it going?
Welcome back to another episode in the GDScript Fundamental Tutorial series. In this episode, we'll be talking about the for loop. So what exactly is a for loop? A for loop is a control flow statement which allows code to be executed repeatedly. Godot uses iterator-based for loops. What this means is that this type of for loop allows for the enumeration of sets of items other than number sequences. In Godot, a for loop is used when you want to iterate through a range, such as numbers, arrays, or even tables. When looping through an array, the current element is stored in the loop variable. When iterating through a dictionary, the index is stored in the loop variable. In Godot, this is what a basic for loop will look like. You have the keyword for, followed by a name for the placeholder, followed by the word in, followed by a range. A range can be anything from an integer to an array to even a dictionary. No matter what, the range is what determines how many times we're going to run the code inside the block statement. This is what a for loop looks like with a number. As you can see here, we have a for x and 10, 10 being the range. What this means is that our block statement is going to execute 10 times. Keep in mind that when using numbers, the variable in the for loop, in this case x, will start at 0 and increment until the variable is greater than or equal to the number used as the range. This is what a for loop will look like with an array. So basically, I hope you're seeing a pattern here, and that's the range is what determines how many times we're going to run our block statement. So in this case, our value x, which can be used in the block statement, will be executed for as many items as there are in the array. And lastly, you can also pass dictionaries into your for loops. And lastly, you can use dictionaries inside a for loop. Keep in mind that when using a dictionary, the value of x will basically be all the keys in your dictionary. So this is what a basic for loop flowchart would look like. As you can see, we're entering through our code, and now we've entered our for loop condition. In Godot, the condition of our for loop is basically, as long as we have not reached the end of our, we update the take a look at variables. Basically, from our examples in the slideshow earlier, I have created a variable for numbers, a variable for an array, and a variable for a dictionary. So let's go ahead and take a look at this example here. So I went ahead and zoomed in so you have an easier time seeing. As you can see here, I have a for loop. In this first example, we'll be looping over an integer. In this case, our value will start at 0 and will execute 10 times. And 10 times it will execute the code in our statement block, which is to print out the value. Basically, we're going to print out all the numbers from 0 through 9. In the next example, we'll be looping through an array. As you can see here, we have a local variable called element, and it will be passed an element starting from the index position 0 of our array, and it will iterate until we reach the end of our array. In this case, we're going to print out the values. Lastly, we have a for loop, which is taking in a dictionary object. Keep in mind that for this for loop, the local variable, in this case key, will be passed the key values of the dictionary object, in this case the indexes. So when we go ahead and print out the key, we'll be printing out the key. However, if you would like to print out the value associated to the key, if you would like to print out the value associated to that key, you'll go ahead and type the standard dictionary brackets key to return the value for that key. Well, that's basically it. For loops are pretty simple. Thank you for watching this episode. I look forward to seeing you in the next. Welcome to another episode in the GDScript. fundamental tutorial series. In this episode, we will be talking about the match statement. So a match statement is a type of selection control mechanism used to allow the value of a variable or expression to change.
Hello, my name is Sam Keene, and this is Explore Game Dev. In this video, we will take a quick but decently thorough introduction of textures and meshes in Godot 4. We will summarize enough of the terminology to get you productive in Godot 4, starting with defining what textures and meshes are and how to utilize them in building your game. At the end of this lesson, you'll have a good foundation to build upon. I'll also leave links in the description for those who want to dive deeper. Okay, so let's talk some terms here before we get started. In this lesson, we're talking about textures and meshes. So what are those? Texture, it's really just a 2D image. It's applied to a mesh. Textures can be painted or generated procedurally through code with what's called a shader. In this example, we'll be using what Godot calls a material, and it's sort of a short circuit to a shader, but you can convert materials into shaders. And of course, in Godot, you can start with a shader if you want, but it's simpler to start with a material, so that's what we'll do. We talked about meshes. What are those? And they're just geometric shapes that can be manipulated in 3D space. And really that just comes down to if we talk about something called a 3D object, like a cube or a cone on the screen, or a 3D character, that's a mesh essentially, which these textures are applied to give them a look of whatever reality we're going for, photorealistic or like an arcade look and feel. Okay, so let's get started here, and in this tutorial we'll be adding just a flat ground plane that you might have a simple arcade style game. You would, place a player up on that ground. In this we're going to add a texture to that so it looks more realistic. Here we're in a new Godot 4 project and we're on 4 beta 6, and so we just create a new 3D scene. Let's rename this to world. Then let's add a mesh instance 3D, and this will be our ground, so let's rename that to ground. So we've already come across a mesh. So what is a mesh? In terms, it's typically short for polygon mesh. You might hear it called that. And essentially, it's a 3D shape, or a bit more precisely, it's a collection of vertices, edges, and faces. And we'll talk a little bit more about that later. But for now, understand in Godot, a mesh needs a shape. And we can see if we look in the inspector, we have mesh here, and then this is where we can choose the shape for it. And there's quite a few different shapes. We'll use a couple in this tutorial. One that's ideal for this ground would be a plane mesh. So we'll choose that as the shape. And we can see it's put this 2-dimensional shape in. It has width and depth, but no height. So again, that's ideal for ground. If we click on it in the inspector, we see all of its attributes. And we can make this a little bigger, up to like, let's say 300 meters by 300 meters square. So now that's much bigger, gives us some room to move around. Right now it renders it as white color, and we're gonna go ahead and add a texture to that soon. So what is a texture? Essentially it's a image file, or we'll soon see it's a collection of files, and we apply discrete image files to our shape, or mesh as it's called. We'll use a process known, or a standard known as PBR, or physically based rendering. This is common throughout the industry. It will essentially simulate the flow of light from the real world onto our 3D shape, onto our mesh. There's aspects of PBR such as reflection, diffusion, and metallicity. Often you might hear these referred to as maps, so they're kind of interchangeable in that I've seen in the documentation. So you might hear of diffuse map or metallicity map versus texture being used for the name, kind of interchangeable. Again, you'll see links in the description that dive deeper into PDR, but just know it's a standard for essentially making these 3D shapes have a texture to them. In this, we're going to go for kind of a photorealism effect. That's often the case, but it doesn't have to be photorealistic. In our case, we will download texture files that someone has created for us, and there's a lot of great sources for that. We will be grabbing one file for the base color of our texture. One will give the illusion of bumpiness, so that'll be another file, and then a final file to show roughness, also known as gloss for our object. So one great place to get textures is a site called Polyhaven. And you can see they have other things, models also. That'll be another video, of course. So if we go into textures, and these are all under a license called CC0, which is a Creative Commons license, which essentially means these are pretty much public domain. So you can really use these for any purpose that you see fit. But you can, when you select certain texture, you can read about that CC0 license to make sure it meets your needs. And we're going to use a texture called Rocky Trail, which is this one. So we go ahead and select that. And you see, again, this is photorealistic. It's a literal image that's been taken and then turned into these files needed by this PBR standard. So we will download it, and the easiest way to do that here is select zip. That lets you select the files you want to get. In our case, we have that, again, that diffuse, which is the base color. And so as soon as you use that, it will look like the image. It just won't have any illusion of depth. That comes in with the normal, often called the normal map. That brings in the bumpiness we talked about. We'll see as we rotate the light, we'll see the shadows effect on the raised parts in this photo. And again, we choose the GL, which is the OpenGL version. DX is the DirectX. Godot uses GL, so we'll grab that one. And lastly, we'll grab the rough texture. So we'll download those three in the PNG format. Okay, so now we've downloaded those files, and in our project, we've created a textures folder just to kind of keep things a little organized. So we'll just grab these and drop them into our project. You might have seen the megabytes. They're pretty large files, so depending on your system, it may take a little while to import. So those are now imported here, and now we can go ahead and put those to use in our project. Before we apply these files, we want to, again, this will be sort of a photorealistic rocky base, and so we want to have something to judge the scale by as these come in. So let's go ahead and add sort of a humanoid stand-in. Again, that'll be a shape, so another mesh instance 3D, and we'll just call this one player. And we know in Godot we have our mesh instance. We need to add a shape to it. The common is the capsule mesh for doing prototypes. And if we look at that, we can see that it's roughly 2 meters high, which is essentially a tall human. We see that we have to zoom in quite a bit, and we go ahead and move this up above the ground plane. So now we have our perspective of roughly what a human size will be. So as we pull in these textures, we can see that, you know, those rocks are about the right size. Also, we want to add lighting, and we want to be able to control that lighting. So in Godot 4, there's a preview lighting in the viewport. We want to control that, so we can sort of import it into the scene with this little dialogue here. So just add sun to scene, and now we see we have that directional light. So let's move it up a little bit. We can see that, and now we can rotate that when we get our texture on, and you can see on the player that shadow respecting where the light's coming from, and we will see as we build up our texture it will do the same thing. So now let's get to what we came here for, applying these texture files to this mesh. And in Godot, a common way to do it in this is to look at our mesh, which is our ground in this case, and it has a material attribute which is empty to start, and we want to add a material, and then we'll actually add the files to that material. So there's three choices here. There's standard material and ORM material. ORM stands for occlusion, roughness, and metallicity, or metallic. These two files, standard and ORM, are pretty much the same, except for the attributes of occlusion, roughness, and metallic are all represented by one texture file, whereas in standard, they each have their own texture file. So not super relevant for us here. We're going to choose standard, but just wanted to call out what that other difference is. Shader material, this shows that actually we're kind of taking shortcuts with this materials. Normally to do highly detailed texturing, you would use a shader to get full control. So you can start out with a shader and just do everything from scratch. You can also take these sort of shortcuts that Godot provides us, these materials, and you can convert them to shaders if you find that you need to take them further and get that full control. So enough said about that. I just wanted you to know what some of those options are. So we're going to choose standard material 3D. And now if we click on that, now we see all these attributes, and this is kind of this is what's representing that PBR format. And again, it's a strong guidance of how to get these textures onto this mesh. You'll see differences across game engines for sure. Some of these names will be different, and as you read up on documentation, some of them will also be different. We talked about roughness might be seen as gloss in some other documentation. Know that there's certainly commonalities, but you'll see differences as you read through the documentation. So just to call out there. So again, enough talk. Let's get some texture on here. So the first one would be the diffuse, or again, we called that sort of the base color. And that is applied, and we talked about names being different. That's applied through the albedo, which is a very common term used to represent color of a texture. It has, you'll see this texture attribute, and here we can see that it's right now it's white, so that's why this plane is white. If we change that color, this would all change. But as soon as we apply texture, that will sort of override that. So we go ahead and click and drag the texture, pop it on here, and you see right away it did render, but it doesn't look like the picture we saw, and you can almost see pretty easily that we're drastically zoomed in. Even if we zoom all the way out to this 300 by 300, we're still way too far zoomed in. So that is fixable, and that, again, that's why we put this humanoid stand-in here so we can tell that this texture scale is wrong for our purposes. To affect that scale, we can go to the UV channel here, UV1. We'll talk not too much about this, but essentially this is U and V as stand-ins for X and Y. X and Y were already taken with coordinates, X, Y, and Z. So the coordinates on textures, they use U and V instead of X and Y. So that's where we can affect the scale. I did some testing, and if we go out to about 60, I think, on each of these, now we see that, okay, that looks more representative of this sort of rocky trail that we saw before. So we're much closer, and you can tune that more to your liking, as you know, up or down. Going up numbers takes you further up, and you want to keep them locked like it is here. Otherwise you get distortion that you probably don't want for this sort of realistic texture. We did mention lighting. We have our diffuse texture applied, so now we see the image essentially, but it's not reactive to light. So if I rotate this, we see the light of the player stand-in rotating, but it's not affecting the texture at all. And this, you know, we want to be bumpy rocks, so we would expect that to happen. The way we can make that happen is if we go back to the ground layer, go to another of these PBR attributes, we're going to pull over the normal. Again, that's what makes it bumpy, to use a simpler term. That would be normal map. So we'll turn on normal, then we'll click and drag the normal map over. Here, you might have seen that effect already, but if we certainly grab the light and rotate that a little more slowly, you see, okay, now it's having the expected effect on those rocks standing up. We see that shadow shifting around them, as we would expect. Lastly, we shall pull over the roughness texture. Look at ground. I think that one's just called roughness. Yeah, there it is. So again, it has that texture attribute. Again, just click and drag it over. Drop it on, and that one, the effect's not as substantial. Often roughness is called gloss. These rocks are very dull to start with. Pulling on that texture doesn't have as drastic an effect, but on close inspection it will look more realistic. So in this case, for this texture, these three files do pretty much what we need. If you had different types of textures, like a metal or something, of course metallic would be a file that, again, someone that prepared that texture for you would probably have the metal texture or the metallic map. And same thing, you would pull that file into here and it would give it that metallic look. Light would behave on that surface as you would expect for something metal. So as you can see, there's plenty of other attributes you can play with here, and I'll leave a link in the description to dig in further into the Godot docs and also in just to PBR in general. And it's just kind of a bonus here. We can quickly kind of get a view from the player's perspective, like a first person or third person. So if we add a camera 3D to our player, and so now that's here, then let's just kind of pull that up, go to like a first person. So let's go right in front, and again, let's look at preview. So there you see, you could be walking around. We don't have movement yet on this guy. I do have a video that goes over the basics of applying movement to a player, and I'll put a link on the screen here that you can add that to the queue to watch next. So thank you again very much for tuning in to check this out. I hope this helped you out with the basics of Hello, in this lesson we will add a global game state storage mechanism to our game. This will allow us to add an option to the start screen for the player to choose single or two-player mode, which we implemented in the previous lesson. Also, we will add an end screen which will show the tally of wins and losses for the X and O players. And again, this is made possible by that global game state storage mechanism. Let's first complete the single player mode feature by allowing the player or players to choose between single or two player mode when the game starts. So in the existing start scene, we will split the start game button into a start single player game button and start 2-player game button. So in the start game scene, start by adding an HBox container. This will auto lay out the buttons side by side. Move the existing start button into this new container and add a new button and rename both buttons accordingly. So on the HBox, set the alignment to center and add some separation of 20 between the buttons. And then finally change the labels on the buttons. Now in the start game script, we will refactor to accommodate the presence of both start buttons. First, we fix the variable declarations at the top of the page. Now update the ready function, and finally address that now we have 2 onStart functions, so we'll add a second and refactor. As it stands now, both buttons will start the game in the same way, but now we have 2 paths, allowing us to alter logic between which path is taken. So at this point we need a way to store the choice of single versus 2-player mode made at the start scene, so then it can be referenced in other scenes and code. So as we did in a previous lesson with the scene changer class, we can use Godot's autoload construct for this. With the class specified as an autoload, it runs in a sort of protected global space, making it available to code in any currently running scene in the game. So let's create a game state class and specify it as an autoload. This will hold the player mode value plus any additional global state values we may need. So create a game state script in the globals directory and call it game state. Again, I add my autoloads to a directory called globals just out of convention to keep track of them, but it's not required. So looking at the code, we use Godot's setGet mechanism to create the property of game mode on this game state class. Additionally, we use an enum to limit the values accepted at the setter for that of single player or 2-player. Now with this code in place, signify this class as an autoload by going to project settings, autoloads, and then specify the path to this class and click add. So now in any running scene, we can use the game state class to set and get game mode values. So let's do just that. In the start game code, we can set the game mode based on which start game button was clicked, by returning to those 2 onClick methods we just created. And now returning to the tabletop scene, we can stop commenting and uncommenting the creation of the computer opponent and instead base its creation on the value of game mode. Now if we play the game mode will change based on the mode you chose at the start scene. Now with the game mode selection complete, let's go ahead and add a quit game button on the start screen. We'll add the quit button below the start button. First add an HBox to the existing VBox. This will allow us to center the button. Next add a button within that and call it quit game and give it the label quit game. Next turn off in the size flags the horizontal scaling so that it no longer expands to the entire container. And then finally set the HBox alignment to center. Now in the start game script, we'll wire up this new quit button. First designate it as an onReady var at the top of the file. Then connect to a local function in the ready function. And then finally create that local onClick function and simply call Godot's provided quit function. Now for a quick test, simply just start the game and then on the start screen just click quit and the window should simply close. Now let's look at leveraging our game state storage mechanism in another way. We'd like to allow the player to play multiple rounds and see a summary of their wins and losses at the end of each round. For this, we'll need a new scene, sort of an end summary scene, to display this tally. So go to Scene, New Scene, and choose User Interface as the starter template. Rename the control to Progress Summary. As we did with the start scene, add a margin container for padding, and go ahead and rename that to padding. For layout, select full rect, and then using the theme overrides, let's give it a margin of 50 all around. As for the layout of the screen, let's design a very simple wireframe to get us oriented. This calls out the data elements that we'll need to store and retrieve for this scene, that of the last winner, and then the tallies for X and O. So we'll get to storing and retrieving those soon, but first let's start with the layout elements of this scene. Start with a VBox container to give us that vertical layout for all our elements on the screen, and let's shorten the name to VBox. Within the VBox container, we'll add the labels specified in the outline, setting their alignment to center and giving them placeholder text. For the play again label at the end with the buttons, let's first add an HBox container, and then in that container place the label and the two buttons, giving them the proper text. And then finally select for that HBox container the alignment of center. As with the game start screen, we'll not be worried about the look and feel at this point, just the functionality. We'll address the overall look and feel in the next couple of lessons. That being said, we have all the elements we need for this screen. Now let's incorporate the scene into our game flow. In the tabletop code, let's change the path of round complete scene path to that path of this scene versus going directly to the start scene. Now for a quick playtest, simply play the game, and on the end of a round, you'll notice you're sent to the summary scene instead of the start scene. So now we need to implement the functionality of the summary scene. Add a script to the top control node, and first add references to the play again buttons and paths to the scenes we will navigate to from this scene. Now implement the ready function, where we'll map local on-click functions to these buttons. Then finally add the on-click function, which sends us to the appropriate scenes. Now we have our game round summary screen. We need to populate the dynamic values within it. Let's start by keeping track of the winner of a given round. First, we'll add a last winner property to the game state class, just as we did with the game mode by utilizing Godot's getSet keyword to add this property. Now we need to record the round winner at the appropriate location. We can set the last winner in the tabletop class.
Maybe I should just make this the damage one. And then I can make another one for damage 2. What's that purple? Is it always? It must have been like that. No, it's not. I don't think so, because I'm kind of tired, but maybe I'll change my mind. It's gonna be so hard to see any of this detail. if and I don't know. I really like how that looks. Instead of doing pink, oh, actually, you know what? I could do something like that on the edge. If I make it pink, which obviously I could do easily, I don't know if I like the transition. Like, I am planning on changing the color, but I'm planning on changing it dynamically. So like what I said before, I was thinking of having the cockpit change color. I can make the cockpit turn pink when it's ready to shoot. is obviously much easier to see now. Though the color just kind of looks weird because you can't tell what it is. I don't know. Alright, let me see if I can figure out the cockpit color. What did I do for the asteroid? Self-modulate. Could do that on the level script, right? Maybe not. Not if I'm using that for, okay. Oh wait, I have to make a different, darn it. on 2D, my bad.
So say you have your scene set up. You have a hallway here, you have room A, you have room B. You go to play your game, you realize, oh no, it's just one sprite. How do I go behind this area here? Well, if we have one sprite, what we could do is we could split it into layers. Or we could use masking. Now the old way of doing masking, you'd get a light 2D, you would get a texture of the area that you want it to cover, you would do a bunch of material shifting. We don't have to do that in Godot 4 anymore. What we can do is we can add a polygon 2D. You go over to data. We'll set down the points that we want first. So we're going to make 2 squares to cover both of the rooms. If you run out of space, you have to add...
Man, this guy's voice. Okay. Oh shoot. Oh. Gosh dang it. Oh, since when did I have that selected? Whoops.
Add more points, and then they'll be over here. You just drag these over. And now we have our points. You'll notice it's all weird and like strange looking. That's because we have to clarify what polygons are what polygons in here. So
That's
the way
nice.
this works is you're going to go to packed int 32. We're going to do that for both of them. Because we have two rooms that are just 4 points each, we're going to set these up so that they are so that it covers each of the squares.
Kind of selecting all the black pixels. So I have collision polygon selected again somehow. Wonderful. How do I... Oh my gosh. Oh, what the heck? How do I keep winding up on the collision polygon? Wait a minute. No. Oh, here. Okay. Size 0. 1, 2, 3. to, or wait.
So we're gonna go there. So these are 1 through 3, and then we're gonna go to 4, 5, 6, 7. So now we have our 2 polygons.
I think I get it.
What we can do from there is we go to
Wait, how's he selecting?
7. So now we have our 2 polygons.
Oh, cause wait, probably because I chose vector. I don't know. I mean, it's gonna take a minute, but I can just. Darn it. This would have been way easier if I had done it like the other way. Oh my gosh. What the? Man, am I dyslexic? I should see it somehow. What the flip? Wait. What? This is affecting the player ship and not the shape. Why?
What we can do from there is we go to visibility, clip children, we set it to clip only, so now they'll turn invisible because they're in clipping mode. We'll take the character itself, we'll put it under the polygon, and now when you run the game, you'll be able to go behind this bar without having to change any of the sprite management or anything like that.
If he was doing just okay. Oh, right, I kind of set that. Probably not ideal if I'm trying to see what it'll look like. What the heck? Okay, I did mess up, I think. Cause I had 0 and 1. I think I was thinking this, wait. Yeah, I think I only did 2 at first, and then I moved on like as if the next shape was, basically I had it starting here. Okay, there you go. Let me just start this over. Wish I understood. That color array. Oh. I'm literally over here like completing my shape for no reason. Don't need to do that. I don't know. Like, that's not gonna be a problem, is it? Oh gosh, those are separate points. Oh. Okay. Right, of course they are. Oh, it should be okay. Oh gosh, but which ones are which? I don't understand why. Can't I just... Oh, okay. There we go. I'm so done. I think I just didn't realize that I had closed it. Or like, you know, reduce the size. The flip. Stop turning the whole thing pink. works. Actually, I might as well. Oh, whoops. Other way around. Right? I really only need one of these. Time left would be in seconds, right? Yep. Let's see, probably like 50%. Or if the laser timer is 0, I can shoot. Which means it would be the other way around. Also, doing something wrong. Wait. Yeah, that should be right.
Welcome to devlog number 12 on Vinny and costume colors. Recently I decided to review how I was handling my character's skin colors, and I ended experimenting 3 different methods: changing the modulate, using shaders, and replacing pixel colors. I will show you how I've done each one of them and what are my thoughts about it. Let me start by the method I was using, changing the modulate. You probably already know about the modulate property. It basically adds a tint to your sprite. The problem with using modulate for skin tones is that it will mess with all the colors in the image. If you watched my devlog number 2 about character customization, you may have seen that my characters are composed of many layers. Some of those layers I call base layers. They are all white, and I change the modulate to define skin tones. Here's an example using a simplified character. This approach works well, but it does add some complexity when animating your characters. It's kind of messy having to jump between layers while drawing, and depending on how you organize your layers, you may end up with more nodes in Godot. The second approach is using a simple fragment shader to change only the pixels containing a given color. In this example here, I defined the areas I want to change as a bright green. You can choose any color, but make sure you choose one that you don't need to use in your assets. In Godot, I created a sprite node with this image, then I created a new shader material, and I set a color replacement shader to it. I then defined the origin and replacement color through shader parameters. You can see in the editor that it worked straight away. And here's how I changed the shader parameter programmatically. Now let me show you the third approach, that's replacing the color in the image. This approach kind of works like the shader, but it only needs to be executed once. And as it's just regular GD script, it does not have the benefit of running in the GPU like the shader. So I'm adding the script to the object I want to change the color. First you need to get your sprite texture, then you iterate over each pixel and change the ones that need to be changed. After that, you create a new texture using the altered image. You need to pass the flags as 0 to disable all the filters so your pixel art doesn't look blurry. Finally, you set a new texture to your sprite node. As I said, the main benefit here is that your color change is calculated only once and not in every loop. However, it does add some code complexity. As I'm creating new textures in runtime, I thought this method would have a drastic impact in memory usage. But in the end, it doesn't change much from the other methods. And in my test, the memory usage was even lower than the first approach, where I have multiple sprite nodes. After implementing all 3 approaches, I made some tests creating items on the fly and moving them around. There's not much difference actually, but keep in mind that that's far from being a real benchmark. As I said, my pixel art uses a low resolution, so it's not that noticeable. In Farstar, I decided to use one of my real skin colors as the color to be replaced instead of the bright green you saw in my example. Using a real skin color helps me to visualize the contrast and values when creating new costumes. And I know this is not one of the colors I will be using in the costumes anyway. If you want to play with this code yourself, you can find it in my GitHub. The link is in the description. I always make these samples available because, as a friend used to say, code doesn't lie. On that note, my sample repositories list is growing, and I'm thinking about unifying all my samples in a single one, or maybe create some kind of index for them. If you have any preference, leave it in the comments to help me decide. I hope this devlog was helpful in some way. If you enjoyed, leave your like. And shader to change only the pixels containing a given color. In this example here, I defined the areas I want to change as a bright green. You can choose any color, but make sure you choose one that you don't need to use in your assets. In Godot, I created a sprite node with this image, then I created a new shader material and I set the color replacement shader to it.
I feel like you know what, let me just I don't really want to do it this way.
Hello everyone and welcome to another episode. I'm Omaris and this week I'm going to share with you a little trick to swap the color on the fly of your sprites in Godot. In my my game Solar Rogue, I have this amazing sprite of a sun that I use in the center of each of my level to represent the solar system. And I think it looks beautiful, but I wanted to give a little bit of pizzazz to each of my level by changing the color of this sun, so that maybe one level is a red giant sun, and then the other one is maybe a brown dwarf sun, and the other one is a yellow solar system kind of sun. I thought that Godot would come with some pre-built palette management system for your sprites, and I kept looking for a node to do that, and I couldn't find any. And when I started looking online for color you set in the modulate, and this is actually really amazing, and I could probably use something like that if I wanted, for example, to give everything in my level a little shade of gray or a little shade of blue or something like that. But to completely change the color, it causes some issues. I've actually tried it with my sun, but since it's mostly yellow and yellow is red and green, well, if I'm trying to do some blue, all I get is black because it's multiplying 0 by blue, and it just makes 0. And I tried to make my sprite black and white so that it would be able to multiply with any color, but then what happened is that the parts that are supposed to be like white hot just become saturated blue or saturated red, and it just doesn't look quite right. Now I got the idea for my solution from a GitHub repository that had a really nice trick. What they did is have the original sprite with the original color, and then they apply a mask on top of it and use the UV of the mask to decide the color. Now the only problem I had with this project was that it's using a mask, and I don't really like the idea of having to duplicate all my sprites. Like, if you have 8 colors anyway, I don't think you really need a mask to decide which part of your sprite is going to be affected by the color change or not. Like, maybe that's just me, but I thought this was overly complicated. So I found a nice little trick. First, I opened my sun in AsSprite, which allowed me to check how many colors it's using, and turns out it's using 11 colors, but 3 of those are just the same color with different alpha values, and there's a setting in AsSprite where you can tell it to ignore the alpha channel. So I ended up with 8 colors, and I just took each of the color of the sun and I pasted them one by one inside my color texture, or my palette if you will. Now, to give me some space to expand in the future, I decided to go with a 4x4 texture, which gives me a possibility of 16 colors. 8 of those are going to be used. Now, this is very important. If you're planning to use a technique like that, I suggest that you go with way more colors that you plan to ever use, because if you ever have to add more color than you can fit in your palette, and you have to go back and redo all your palette, you're going to cry. So if you're in doubt, just use a 16x16. That gives you 256 color, which should be plenty enough. Now the nice trick is that you have to go back to your original sprite and change each color to something that's going to be the equivalent of a UV coordinate inside your palette texture. Now the way you do that is with a little bit of math, which I'm going to try to explain right now. You see, UVs are just a coordinate system inside the texture. So the 0, 0 is the upper left corner, and the 1, 1 is the bottom right, and 0.5, 0.5 is the middle. And then the colors are also just a number, right? So usually you're used to thinking of colors maybe in hexadecimal, like pound FFFFFF for red, green, blue channel. But each channel is actually just an 8-bit value, which is between 0 and 255. But you can easily represent this value as a floating point between 0 and 1 if you just divide by 255 and 1. But into indexed, and I took each color and I changed the color. My sprite behavior in the code that's generating the sprite when you load the game, I added a condition that if there's a list of palette, it's going to set the material and the shader property for the uniform to the value that it chooses randomly from the list inside the JSON. And that's pretty much it. It just works, and now every level
man. This must be... It shouldn't matter. Man, what the heck? I get it. Whoops. Why doesn't it do anything?
Hello and welcome to another Godot tutorial, this time about a plugin called SmartShape2D. In the beginning of this video I show you the asset creation.
What's a plugin?
Hello, I'm going to show you a simple, we'll show you the node. So that's approximately 256 size.
Get a viewport container, add a viewport, and to that viewport add whatever it is you want to occlude. You may have to toggle stretch on the viewport container in order to make this actually appear. To the container add a shader material, and to that a shader, and to the shader this text. Shader type canvas item reveals that this is a 2D shader. This uniform will allow you to specify the mask. This first color line simply sets the color to what it would ordinarily be. The mask is upside down by default for some reason. These two MUV lines undo that. This final line sets the opacity equal to the redness of the mask at this point. So white areas of the mask, which have a red value of 1, will remain opaque, but black areas with a red value of 0 will be fully transparent, with the effect scaling as you would expect with the various shades of grey. There you go, masks. Now your games are able to participate in masquerade ball. Container add a shader material, and to that a shader, and to the shader this text.
Okay, I didn't realize that that's how you get there. Even if I do that, I don't know how to manipulate it.
Shader type canvas item reveals that this is a 2D shader. This uniform will allow you to specify the mask. This first color line simply sets the color to what it would ordinarily be. The mask is upside down by default for some reason. These two MUV lines undo that. This final line sets the opacity equal to the redness of the mask. mask at this point. So white areas of the mask, which have a red value of 1, will remain opaque, but black areas with a red value of 0 will be fully transparent, with the effect scaling as you would expect with the various shades of grey. There you go, masks. Now you're
No Raid Shadow Legends. A lot of that stuff's... Oh, because I didn't like set it to empty. Called for every pixel the material is visible on. Called for every pixel for every light affecting. Interesting. Dude, I swear, I'm like, this is not what I want. Like, this is so much more complicated than what I'm trying to do should be. Maybe, I mean, what would I use? How? I don't understand that. How can I add a child to this and have it not affect the parent, yet affect the parent of the parent? Or, I don't know, why is it affecting the entire tree? Makes no sense to me. All its parents share a layer with the viewport's canvas cool mask. What? Okay, I swear I said that to 3. Viewport will render a canvas item if it and all its parents share a layer with the viewport's canvas cool mask. That's why I keep thinking it's called Shape 2D, is because I set the name wrong, or I changed it at some point. Whatever, I'll just keep that. I don't get it. It must be something to do with this and how I didn't use all the points or something. Well, okay. I mean, in this example, I did use all the points. Hang on. What the heck? Maybe if I remove those. What? What freaking point is that? Alright, let me just restart this. Did that make another point? No. Like now it doesn't show me the number for some reason. Right, should be 2. What the heck? I'm so confused. What the fuck? Okay, what did I do? What? What? What am I doing? What did I don't get it. Dude. There's no way. Is there some way I can copy? Just like copy the data from here to the other one. What in the world? Oh yeah, I have less points on here. Oh boy. I mean, maybe I should just... Oh, wait. Should definitely do a brighter color. It really doesn't stand out very much. What if I made the alpha, well, hang on. It doesn't matter if the alpha goes negative, because that literally just means nothing. Like, it's definitely kind of a problem how much it overwrites the black. Oh. Interesting. Wait, why is it? Oh, wait. In certain positions, the pixels line up differently because it's I didn't follow the same pixel grid that the ship has, I guess. Wonder what it looks like with anti-aliasing. Pretty much the same. Which makes sense. Let me make it smaller. Oh, I forgot I changed that. Jeez. Oh. I swear that looks the same. The heck? What is it? Thought I moved them a decent amount. Huh. Yeah, I don't really get it. It's definitely different, but wait, what? How did that become purple? Oh, 0.1. Whoops. There we go. Okay. Time left should be like it shouldn't quite reach that color until after the cooldown ends. So I should add to this. very annoying to have the music playing over the top of the music. Let me just change the color so it's more obvious for now. Okay, that should be exact, I think. So as soon as it hits maximum alpha, it's ready to shoot. Which I think I would want... If I did something like that, that's an extra fifth of a second. Oh, that's actually going too far, because then it can never get... Man, I'm so bad at like being able to tell the difference. What if I did... Let's see, as the timer decreases... What would this be like? Yeah, this kind of has an issue. I can't, whatever, this is good enough. Oh wait, I could add... The same tween is not meant to be used more than once, right? Let me just make a new timer. Nope. Oops. Ooh, this feels like a bad way of doing it. But let me do like another particle. I might as well leave those. No, I don't. Well, yeah, I don't need that. It's been 5 hours, so I'm gonna stop.